Hi, hello everyone. Welcome back to our channel Chemistry Made Simple for NEET, and this is Dr. Radha Subramaniam with you with another session of NCERT chapter first class 12 lesson 1 solid state. So, we have already uploaded a few sessions of the most important concepts from this lesson, and we were talking in our last sessions about some FAQs of NEET exam. Many students are asking doubts regarding the preparation and about the doubts regarding the NEET 2022 exam application forms and things so on. So, today we will just take up a few questions regarding NEET exam, and a few important tips for the exams would be: how many hours should I study for NEET? Experts suggestion is that every day at least 5 to 6 hours of sincere study can be fruitful in achieving a good score. And what should be the daily routine to crack the exam with a good rank? So, in order to succeed, the students should have a solid strategy which will guide you through the preparation journey. The daily routine for different students can be of different methods. The key or the most important thing is to find what works best for you. Studying early in the day often helps, and regular intervals in the study schedule helps in the long run. And you have to study and practice for the NEET exam with unwavering focus. And many students ask that can anyone crack NEET exam without coaching? Yes, of course, it is possible to crack NEET without any coaching, as it is up to the student that how much she or he should prepare for the exam. NEET exam is tough, but your dedication will surely lead you towards success. Then how can you work on the time management for the exam? One of the greatest challenges for the entrance exam is the time limitation. You have to complete the questions with the stipulated time duration and practice NEET sample papers and previous year question papers to improve time and accuracy. And also you have to be regularly practicing and revising all the concepts, which is most important thing that you have to do for the exam. So, with that we will start today's session with the types of point defects. Okay, so the first one is stoichiometric defects, and these are the point defects which do not disturb the stoichiometry of the solid, and these are also known as intrinsic or thermodynamic defects. So, basically there are two types: vacancy defects and interstitial defects, and last class we had stopped at vacancy defects. So, what is a vacancy defect? Now, some of the lattice sites are vacant, so then the crystal is said to have vacancy defect. So, because of this vacancy defect, it results in the decrease in the density of the substance, and also this defect can develop when a substance is heated. Then interstitial defect. So, some constituent particles like atoms or molecules will occupy an interstitial site, and the crystal is said to have interstitial defect, and because of this defect the density of the substance will increase. Okay. And vacancy and interstitial defects, these as explained, it can be shown by non-ionic solids also. Ionic solids always must maintain electrical neutrality rather than simple vacancy or interstitial defects. They will show these defects as FRENKEL and SCHOTTKY defects. Already we talked about SCHOTTKY defects in the previous session. Okay, now impurity defects, like in molten sodium chloride, it contains little amount of SrCl2, that is crystallized. Some of the sites of sodium ions are occupied by Sr2 plus, and each Sr2 plus replaces 2 sodium ions, and it occupies the site of one ion, and whereas at the same time the other site will remain vacant. So, the cationic vacancies will be equal to the number of that of Sr2 plus ions, and similarly you can see such examples with CdCl2 and AgCl. So, impurity defects, and see vacancy here and interstitial impurity, which is shown in blue color. This is all very simple concepts. Okay, now see interstitial defects, you can see that here it is vacant and these two are interstitial impurities. Now, what is meant by FRENKEL defect? FRENKEL defect is also it's shown by ionic solids. The smaller ion, that is cation, that is dislocated from the normal side to an interstitial side. So, because of that because of the dislocation, a vacancy is created at the original site and a new location and interstitial defect will be found. And FRENKEL defect is also called dislocation defect, and it does not change the density of the solid. FRENKEL defect is shown by ionic substance in which there is a large difference in the size of the ions ZnS as AgCl, AgBr, AgCl because of the small size of Zn2 plus and Ag plus ions. I hope this is clear to you, and you have now understood what is meant by FRENKEL defect. Okay, because so many types of defects are there, don't get confused. Okay, you just revise a little by little every hour or half an hour. Don't sit and read everything in a single stretch, because you will feel so confused that you won't be able to recollect the whole concept. So little by little, if you revise it very often, you can easily remember these concepts. See, FRENKEL defect, you can know vacant site is created and it is transmitted to another place as shown in the figure. Okay. Now already we talked about SCHOTTKY defect, and that is basically a vacancy defect in ionic solid. To maintain electrical neutrality, the number of missing cations and anions are equal. So like simple vacancy defect, SCHOTTKY defect also increases the density of the substance, and number of such defects in ionic solid is very important. Like in NaCl, approximately 106 SCHOTTKY pairs per cc at room temperature, and in 1 centimeter cube there are about 1022 ions, and there is one SCHOTTKY defect per 1016 ions, and this is mainly shown by ionic substances, because here in ionic substances mostly cation and anion will be almost similar size. Like examples are given here, and AgBr will show both the FRENKEL as well as SCHOTTKY defect, because you know for the exam they will ask you which is the compound that shows both these defects. Remember the name AgBr. Now imperfections in solid. Okay, point defects, these are the irregularities or deviations from the ideal arrangement around a point or an atom in a crystalline substance. And what are line defects? These are the irregularities or deviations from ideal arrangement in entire rows, and these irregularities are called crystal defects. You can see here. Okay, and the figure is given for your easy understanding. And defects in solids, see, it can be classified impurity defects, stoichiometric defects and non-stoichiometric defects, whereas stoichiometric defects are classified into these four. Already we discussed all this, and non-stoichiometric are classified into these two: metal express defect and metal deficiency defect. Okay, now what are non-stoichiometric defects? See, metal excess defect is due to anionic vacancies, because alkyl halides like sodium chloride, KCl, these two show such type of defect. What happens is that when you heat the crystal of NaCl in an atmosphere of sodium vapor, the sodium atom will be deposited on the surface of the crystal. What will happen to chloride ion? That will diffuse to the surface of the crystal, and they will combine with Na to give NaCl. So how does it happen? By the loss of electrons by sodium atoms to form Na plus ions. The released electron will diffuse into the crystal and they will occupy the anionic sites. Okay, clear? Now because of the crystal, now it has excess of sodium, so the anionic sites occupied by unpaired electrons are called F centers, which imparts yellow color to the crystal of NaCl. You saw that in the diagram which I showed you previously, and the yellow color of the crystals, because the color, why it is happening? Due to the excitation of electrons, they will absorb energy from the visible light falling on the crystals, and similarly excess of lithium make lithium chloride crystals pink, and potassium excess will make KCl crystals violet or lilac. So this is an important concept, do remember this. And metal excess defect due to the presence of extra cations at interstitial sites, like zinc oxide is white in color at room temperature. When you heat it, it loses oxygen and turns yellow. And see, now excess of zinc is there in the crystal, and the formula becomes Zn 1 plus XO. Excess Zn 2 plus ions will move to the interstitial sites, and the electrons to neighboring interstitial sites. See, I have made these notes very simple for you, that can just reading with full amount of concentration makes you easily follow these concepts really well. So with that we are concluding this session, and do like, share and subscribe to our channel Chemistry Made Simple for NEET, and for more such videos do subscribe, because I have watching many of the students are just visiting the channel without subscribing. Such students, please do subscribe to the channel. Only then when I post new videos you will get the notifications immediately. And thank you very much for all your support and encouragement. I am really happy to see the excellent response from all of you, and I would like to thank each one of you for supporting our channel. Thanks for watching.